3, 2, 1, let's go! Hi everybody and welcome to another exciting edition of Boring JavaScript. I'm your host, the Virtuoid, aka Mike Smith, and today we're going to be talking about data types in JavaScript. Now there are 9 different types. 6 of them are primitive, 2 of them are structural, and the last one is a structural primitive. What does that mean? I don't know, but we'll find out together. Are you ready? Let's get started. The first one we're going to look at is the Boolean variable. Now what's a Boolean? A Boolean is a primitive type that is either true or false. That's it, just 2 values. So this should be a really quick example. First of all, I'm going to set my 2 variables, one called isTrue and isFalse, to true or false. And these are the only 2 values you can set for a Boolean, either true or false. And these happen to be reserved words in JavaScript. Now, to prove everything is a Boolean, I'm going to first use the type of operator within JavaScript, and the type of will tell me the type of the variable, whether it's Boolean, string, number, whatever in that case. So throughout all these examples, I'm going to be using type of to show you that indeed it has created a particular type of data type and what the actual value is. And for Boolean, of course, being true or false, that's it. So there really is nothing else. You want to see how it works? Well, let's see what happens. Let's type in node Boolean. Wow, yeah, there it is. isTrue is a Boolean. There it is. And the value is true. Yep, that's right. isFalse is a Boolean, and the value is false. So as you can tell here, we will use the type of to show you what type of variable has been created, Boolean, string, whatever. And then, of course, we're going to print out the value. And we'll be doing this for all of the different examples we're going to show here. So that's all there is to a Boolean. That's your first primitive data type. Let's get on to the next one. Next, let's take a look at the number data type, and we're going to include this with also the newest addition to numbers called big int, and I'll explain that here in just a minute. Both of these, the number and the big int, are primitive types, and let's take a quick look at them. The number type can be represented in 2 different ways. The first way is as an integer, which is basically a number without a decimal portion, and a floating point number, which is basically a decimal with a variable with a decimal portion there. And that's basically all there is to a particular number. The big int, by the way, is a new type of data type, primitive data type, that allows you to go beyond the normal range of an integer. Now, an integer has what they call a maximum safe integer number. It's in the 9 quadrillion or something like that. But sometimes, especially for scientific calculations, you may need to have integers that go far beyond that, into the quintillions, sextillions, septillions, whatever in that particular case. So the big int was created to be able to handle those, and I'll show you that in a second. The difference between a number and a big int is the letter n at the very end of the number declaration. So in this case, where my integer was just a simple number 1, my big int number is the number 1 with an n at the side of it. And that will also actually give me a number 1. And this particular equation here is 2 to the power of 68. And I just did this so I can give you a really huge number. And I'm going to use the console dogs to print out here. And I'm going to show you what the type of integer, type of float, and type of big int comes out to be. And I should have integer, and then big int with the values. And then I'm going to show you a couple of interesting constants you have inside numbers. For instance, within the number, you can have a maximum and minimum value. And this is the maximum minimum value you can have for your numbers. And these particular ones are floating point. Max safe integer and max minimum safe integer are the 2 numbers that are the maximum safest integers that you can represent with a number. And I'm going to print out my super number here to show you that it will indeed go beyond the maximum safe integer. You want to see how it works? Let's take a look. Let's go to node numbers. And sure enough, my integer type is a number with a value of 1. That's correct. The float is also a number. Remember, floats and integers are not 2 separate items. Data types. They are the same data type, so that's why I report a number, and it's a value of 1.4. My big int is a type of big int. It shows that the big integer is a completely separate data type from integer. So here is the maximum number value. That's a number I'm not even going to try to talk about. Same thing here. Here is the maximum safe integer, and this is important because remember, big ints can go beyond this number, but this is the largest number you can get with a regular number, and that's 9 quadrillion, 7 trillion, 199 billion, 254 million, 740,991. My superint, remember that was the one that was, I believe, yeah, 2 to the power of 68. As you can tell, this number is significantly larger as the safe integer, which proves that you can go above that. What is that number? That number happens to be 295 quintillion, 147 quadrillion, 905 trillion, 179,352,825,856. That's a mouthful. So these are the two more primitive types, number and big int. Let's go show you another type. Next, we'll cover the string data type. Now, the string data type is a primitive type again that contains textual data. It contains alphanumeric characters, special characters, just about anything you want to put into a string can be put into a string. And you can specify a string in JavaScript in one of 3 ways. The first way is to enclose your string within double quotes. And this is convenient if you happen to know your string contains single quotes. You can also put it within single quotes, and that's nice if you happen to know you may have double quotes within your string. My preferred method, which is a more newer method, allows me to put in the string within what they call backtick marks, and this is called templating within JavaScript. And by templating, I can put absolutely anything I want between the tick mark and another tick mark. In fact, I can even put JavaScript variables. As you can see here, this is the syntax you use to put JavaScript variables. So this very last my template will have the word combination, then we'll have my double quotes string, which is this, and then we'll have my single quote string, which is just this. And again, we're going to do the type of here to show you that indeed each one of them is a type of string, and then we're going to print it out to see what happens. So you want to see what happens? Let's take a quick look. Let's type in node string. And sure enough, that's what happened. The double quote string, it was a type string. The single quote string was a type string. And the template code was a type string. And as you can tell here, it did combine all of those, the single quote and the double quote into one string. So that's all there is to the string primitive data type. Let's go to the next one. Our next data type is a symbol data type, and it's also, again, a primitive type. And a symbol in JavaScript allows you to create a unique immutable object. Now, what do we mean by unique immutable? Well, basically, unique means that you can never reproduce it. So nothing can be equal to another one. Immutable means you cannot change it. Then these values that you initially assign to these symbols can be just about anything. They could be booleans, numbers, objects, functions, whatever. Now, I'm not going to go too much into exactly what a symbol is, but I just want you to know that a symbol is a primitive data type, and we'll show you that here in just a minute. Now, here I have created with my 4 different symbols. The first one I've created is a symbol passing a 1 as the initial value. Here's a symbol created off of a string. Here's a symbol created off of an object. And here is another symbol created off of a number 1. So I have a number 1 here and a number 1 here. And I'm doing the same thing I've done with the other examples, is I've done a type of here to show you that it would be a type of a symbol, and printed out the symbol value itself. I did add one extra thing here, kind of want to show you here, is that notice the first symbol I have here says this is going to be symbol number 1. The second one here says I'm going to have a symbol number 1 also. So I should expect this to come out to say that they are both equal, since both of them are symbol number 1. You want to see how that works? Let's take a look. Let's go into Node and type in node symbol, and there it is. Each one of them can be a type of symbol. It's a symbol of 1, a symbol of test, and a symbol, of course, object. And oh, they're not equal. Now, why is that? Well, remember what I said. Symbols are unique and immutable. Immutable means they can't be changed, but unique means that you're unique. So if I had a symbol of 1 and another symbol of 1, they'll never be equal. I can create 1,000 symbols of the number 1, and each one of them would be completely separate. Now, why would you do that? I have absolutely no idea, but hey, there we are. So that covers symbol. Again, symbol is also a primitive value. Let's go to the next one. Let's cover the last 2 of the primitive data types, and that's called undefined and null. First of all, undefined. Undefined is a primitive data type. You can actually assign a variable to be undefined. And that gets a little tricky. You usually don't do those kind of things, but hey, it's possible, so there we are. But I do want to talk about null for a second. Null is actually a structured primitive. And what I mean by a structured primitive? By that I mean that it is reporting itself as a structured variable. And a structured variable is an object, a function, or even an array or something like that. And I'll cover those a little bit later. But when it is in operations, it operates like it's a primitive data type. And I'll show you the difference between a structured and primitive data type at the very end of this video. So let's just go through it here real quick. How do you assign a null value? Just assign it equal to null. That's it. How do you assign an undefined value? Just assign it equal to undefined. Here are my type ofs. The type of null, I do not expect to come out to say null. I expect it to come out the object because it is a structured data type. Undefined, I expect to come out as undefined and null and undefined. But I want you to take a look at this here real quick. I'm also constant logging my undeclared is type undeclared. Now, where is my undeclared? It's not defined anywhere. I kind of want to show you this in the sense that you can always assign a variable to undefined, but an undefined variable will throw an error, which basically means that a variable that has not been physically defined within the JavaScript space will always throw a variable. But if you physically define a variable like that, you can always declare its value as being undefined, and that is a legal primitive value. You want to see how that works? Sure you do. Let's take a quick look. Let's go in the node and go node null. And wow, something happened here. First of all, my null is a type of object, which I expected because, again, it's a structured primitive and the value is null. My undefined is a type undefined, which shows that it is indeed a primitive or a data type, and the value is undefined. And here is where it threw the error, which says my undeclared type is not defined. So again, what was the difference between my undeclared being not defined throwing an error and my undefined variable saying that the value was undefined? Again, it depends upon whether the physical variable was declared or not. My undeclared or my undefined was physically declared, just assigned a value of undefined, but my undeclared is never been defined. And that's what this is really talking about here. It's saying that, hey, this variable was never declared anywhere within the JavaScript, as opposed to this variable, which was declared, but just given a value of undefined. A little tricky there, but that's the last two of the primitive data types, null and undefined. Let's go to the structured data types. So let's talk about the structured data types. We have two structured data types, the object and the function. Let's take a quick look at both of them. Here is an object, and again, an object in JavaScript is nothing but a collection of key value pairs. It's actually a lot more than that, but again, just for simplicity purposes. A function is a stored set of code that you can execute, and it should return you a function or not. An arrow function is a shorthand method of doing a function, and there's a lot more to it than just a shorthand method of doing a function, and I'll cover arrow functions in another Boring JavaScript at some time in the future. When I print these out, I should expect the type of object to become object, type of my function to be function, and type of my arrow function to be function. But I want to show you just really quickly here just something a little bit different. Here is another variable called my other object that I've also set to have the properties of A and B, or the keys of A and B, with the values of 1 and 2. Exactly the same as my object A and B, my object up here with the keys of A and B with values of 1 and 2. So this statement down here, I should expect them to come up be equal, right? Well, let's take a quick look. Let's flip over to node. Let's go over to node and type in node object. And yep, sure enough, my object is object, my function is function, and my arrow function is function, but notice the two values are not equal. And why is that? Well, when JavaScript creates values, when it compares two object values, it really only compares the fact that, both of these are objects. It does not go into a deep compare. And what we mean by deep compare is it does not look into the actual properties or the actual keys of those objects to find out if they're equal or not. So in my case, my two objects both had keys of A and B and had values of 1 and 2 respectively. But since JavaScript doesn't dive into the variables to find out if they're equal or not, as far as it was concerned, no, they're not equal because, because I've got one object here, it's an object, but I got another object here, it's an object too, but they both got content, so the content's not equal. So objects, although they may have the same keys and the same values with those keys, are never equal to each other. You have to manually go in through the properties and make sure they're equal. But other than that, that's really all there is to the structured data types, object and function. Now, why is there structured data types and why are there primitive data types? There's a very important distinction, and let's cover that next. So what's the difference between a primitive data type and a structured data type? Well, it depends on how JavaScript works with the variables. For example, let's say I had let A equals 1 and then let B equals A. That assignment where I assign A into B is different depending on whether you have a primitive variable or a structured data type. Data type. Primitive data type and a structured data type. Best way to show you two is through examples. Let's take a look at our code first. Let's take a look at the primitive ones first here. I have my data is equal to 1, and I'm going to do a little printout saying, hey, before I do anything, that this is going to be the value of my data. I'm now going to say, let my data equal my new data equal my data. And then I'm going to change my new data to 2. I'm going to print out my new data and then what happens to my data afterwards. Now, why am I doing this? Because JavaScript will treat things differently based upon whether it's a structured data type or a primitive one. Now, for a primitive one, it makes a physical copy of the value before it assigns. So I have the value of 1 here inside my data. When I say let my new data equal my data, that makes a physical copy of my data. So now I have 2 distinct unique variables. One called my data, one called my unique data, my new data, each one having 2 values that are completely separate from each other. So if I was to run this, I would expect this to be 1, this to be 2, of course, because I have an assignment of 2, and this to stay 1 because my data has absolutely nothing, my new data has absolutely nothing to do with my data. We'll see if that works. Let's take a quick look. So if we go into node, compare primitive, I hope I can spell this right. Yep, sure enough, my data before is 1, my new data is 2, and my data after is 1, which is exactly what we expected. And this works for all primitive variables. All primitive variables, when you make assignments or pass it to a functions, will make copies of the values and throw that copy into the new variable. And that works for numbers. If we go inside here, that works for string. So if we say string, and we go back down here and say new string, if we run it, oops. See? No change. Even works with null. Remember earlier I said that null is a structured primitive. It's a structured variable, but it works like a primitive. So if I was, well, let's just keep it like that. If I say my data is equal to null, and then I come back and say my new data is equal to new string, since it acts like a primitive data, I should expect my data not to change. Let's flip back over to null and take a look at it. Let's clear the screen off and let's go back to node. Sure enough, the data before is null, the new data is new string, but my data has not changed. So that's how primitive data types work, is that they make copies of the values. Obviously, structured is different. Let's take a quick look at that next. So structured data types work different from primitive data types in one very important point. Now remember earlier I said with primitives, if I said like A equal to 1, and then let's say B, and then we said B equals to A, that JavaScript made a physical copy of A and put that into B. Well, that's not the case for structured. Structured does not make physical copies of the values when it assigns it to new variables. What it does is that it passes what we call a reference. And what do we mean by reference? Well, in actuality, physically within memory, you have the variable itself. We'll just, for example, let's just say my data here, highlight that. You have in memory the physical data itself that says my data, and then it points to a copy of the physical data itself in memory. And with the primitive data, what JavaScript will do is take that physical memory and copy it over to somewhere else. But with structured data, what it does, if I say let B equals A, it creates B, but then B gets pointed to the data itself. So instead of making a physical copy of the data, B now points to the data itself, because what A passed was not a copy of the data, but A passed a reference. A said, okay, I'm a structured data type, so here is the pointer to all my data. Go have some fun. And that's great. That saves memory, especially if you have very large data and everything. But there's one thing that you got to be very careful of, that you got to remember on how it works. That if you change that second variable, or a property within that second variable within the object itself, if you change a value, because you're pointing back to the original data, you're changing the original data. So not only will your new variable change, but your old one will too. Let's see exactly how that will work. So here is my object called my data, and it is an object, and I've got one property in it. I've called it property 1, and I'm just doing the before. I'm making the assignment just like I did before, and I am changing the property value from 1 to 2. Now again, because JavaScript is passing a reference to the original data, we are working with the original data, not a copy of it. So my data.property changed to 2, but because we're working with the original data, my data.property has also changed to 2. So I should expect this console.log to become 1, this console.log to be 2, which is what I would expect. Actually, I'm doing JSON stringifies. You'll see it here in just a minute. But this third one here, when I do the console.log, my data.property, you will find out, will change. And let's just take a quick look and see what happens. So let's go into Node, type in Node, compare structured. Yep, that's exactly what happened. Before, my property was 1, which is I expected. I changed the property to 2 when I passed in new data, but because the structured variable passes references to the original data, I'm working with the original data. So therefore, not only does my new data have property equal to 2, but my original data also has property equal to 2. So that's one thing you've got to be very careful of and watch out for, is that if you're using structured data, and this is objects or functions, and an array, for example, is an object, just FYI, whenever you pass that to your functions, or if you pass that to new variables, if you were to change the values within that object, or if you were to change the values within that function or anything like that, don't know what you'll do with the function, but if you change the values within an object, not only are you changing the one of your current variable, but you're changing the original one again. Now you can use that trick to do some really great stuff with JavaScript, but you can get in trouble real fast if you think you're changing a completely new variable as opposed to an old one. And there's plethora of ways to be able to physically copy objects that I'm not going to cover here. You can just Google it and take a look at it. It's called deep copy. Google deep copy and you'll be able to figure out what's going on there. But that's the big difference between structured data and primitive data. Primitive data copies the physical value. Structured data copies a pointer to the value. So any operations you do will operate on the original data. And that's the difference between structured data and primitive data. And that's all there is to data types in JavaScript. I hope you enjoyed our video. Hope I didn't bore you to death. Please visit our website at www.boringjavascript.com for all of our videos. Subscribe to our YouTube channel or check out everything at blog.thevirtuoid.com. Thanks again for watching and we'll see you later.